The term like radicals is exactly what you're going to think of when you think of like terms with variables, all right? Radical expressions have the same index and the same radicand. Remember, the radicand's the guy on the inside, the index is the number, and the little tiny number on the outside. If they have, so think about with variables, they had to be the same variable with the same exponent to be considered like. So for radicals, it has to be the same index, and the guy on the inside has to be the same. And then you add them just like you would add variables. You add their coefficients. So the guy on the inside doesn't change. The number on the outside is what you add or subtract. That's as simple as it is. So if you look at this first one, we have an index of 3 for both of these. Check. On the inside, we have an x. Done. Those are like radicals. So now I just have to add them. I have 5 of them minus 3 of them. So how many of them do I have? 2 of them. Make sure you write everything exactly the same. Put that little index there. This guy doesn't change. I say that because this is one of the number one small errors you get counted off for, and it's a third off if you leave that index off. Okay, so that can add up in a quiz or test. So make sure you end and check that you have put your index in there. All right, this guy right here, it is both square root because we have no index. On the inside, we have a 2 and a 3. Those are not alike. So when they are not alike, this is as simple as it gets. That is your answer. You can't add them. Just like if it were 4x plus 5y, you would say, okay, it's 4x plus 5y, I'm done. So let's look at this one. We have 6 square root of 18 plus 4 square root of 8 minus 3 square root of 72. Just briefly looking at that, you would say I can't add them. However, what you'll notice is they are not simplified. So I can make these more simple than they are, all right? Which means before I decide if I can add or subtract them, I need to simplify them. So I am going to use my factor tree to simplify. The 18 is 2 and 9, 3 and 3. The 8 is 2 and 4, 2 and 2. 2 and 36. I'm just going to do 6 and 6 there because I know that's a perfect root. All right, so I am going to here take out a 3 and leave in a 2. I already had a 6, so 6 times 3 gives me my 18 square root of 2. It's a plus. I can pull out a 2 here. There's already a 4 out, so 2 times 4 is 8. On the inside, I have a 2. I can pull a 6 out here. 6 times 3. That also gives me 18. And on the inside, I have a 2. And lo and behold, I have like terms, right? Like radicals. And so before you decide can I or can I not, make sure that all of them are in simplest form because it's possible you could add some of them at least to simplify. So now that I have that 18 plus 8 minus 18 is just going to be 8 square root of 2. Right? So for multiplying, you're basically going to FOIL, just like you would if this were any set of binomials. When you multiply radicals, you multiply the outsides and the insides, which is kind of what we did in the other section, right? So remember, if you multiply radicals, you can multiply the coefficients and you can multiply what's on the inside. And then you're going to want to simplify, right? So I'm going to FOIL this just like I would any other binomial. 3 times 2 is going to give me, let's do it with a different color. 3 times 2 is 6. 3 times 4 square root of 5, I'm going to say is 12 square root of 5. Just multiply the outsides there and the insides. 2 square root of 5 times 2 is going to be 4 square root of 5. And then 2 square root of 5 times 4 square root of 5. 2 times 4 is going to give me 8. And what is the square root of 5 times the square root of 5? Just 5. So that's going to become 40. All right, so just pay attention when you have square root times square root. They sometimes completely simplify out. Then I'm going to combine like terms. Well, now my like terms consist of a 6 and this 40. And these are also alike, 12 square root of 5 and 4 square root of 5. All right. So conjugates are simple. This concept we've done, I don't even know how many times. So if we have conjugates, a plus b, a minus b, like, I don't know, a plus 3, a minus 3. It ends up being the first one squared minus, always minus, the second one squared. Anytime it's conjugates, no matter what's inside there. If they are exact and the only thing changed is that center, it's always going to be the first one squared minus the second one squared. So first one squared, when I have this, it's 2, it's square root of 3, it's a plus, it's a minus. There we go. It's conjugates, okay? So the first one squared, I can FOIL. I mean, let's say you forget this, you can FOIL it, but your middle terms are going to cancel. So the first one squared is just 4, always minus. The second one squared, what is the square root of 3 if I square it? So my answer here is 1. So we've talked about the fact that radicals in the denominator are not considered simplest terms, all right? And so we've rationalized just a square root over a square root like you did for homework, where you had to multiply top and bottom by the denominator. In this case, however, though, we have a binomial in the denominator. And so the way you get rid of it, you just saw what happened when I multiplied conjugates with a radical in it. Well, my radical went away and I just had this number, right? And so what I'm going to do is I'm going to do that process on this fraction here. I'm going to multiply the top and bottom by the conjugate of the bottom because my goal is to get the radical out of the bottom, okay? So I am going to take this guy here and I am going to simplify him by multiplying the top and the bottom by the conjugate of the bottom. Now keep in mind, you only change the middle sign. And I say that because if that had been a -1 minus square root of 5, 50% of the people at least will change that -1 to a positive 1, all right? You only change the middle sign when you're doing a conjugate. You don't change the first sign, okay? Conjugate's just the middle sign. All right, so on the bottom, that's really simple. I know what my denominator is going to be. It's going to be the first one squared, 1, minus the second one squared, 5, okay? And on the top, I'm just going to FOIL like I did when I was multiplying the binomials. I'm going to say 3 times 1 plus 3 times square root of 5, 5 square root of 1, and square root of 5 times square root of 5. So on the top, I'm going to get like terms. 3 and 5 is going to give me an 8. 3 square root of 5 and 1 square root of 5 are going to give me a 4 square root of 5. And on the bottom, I'm going to get a -4. Now, you can do this 2 ways. If you are reducing, first of all, you can't reduce from inside the radical to outside the radical. All right, so unless the radical is something you can simplify, like 8 or 12 or something that you can simplify, leave him alone. For outside the radical, everything has to simplify. So you can't just do this 4 and this 8, like if that other 4 weren't there. You can't do part of it. It has to come out of everything. So in the book, it shows you to separate them. 8 over negative 4 plus 4 square root of 5 over negative 4. Okay? If that helps you realize that you can only simplify it like this, or you can take a 4 out of everything. But it ends up being 8 over negative 4 gives me a negative 2. 4 over negative 4 is a negative 1 square root of 5. And so this is my answer. You can do it here. Just keep in mind this is a negative, right? And that's going to become a negative. All right, but it has to come out of everything. So go ahead and try check understanding number 6.